Good afternoon. Welcome to our week 4 Future of Database Design and Database Management. As part of the theme discussion for this week, my name is Joseph Bucher and I have Sherzod Sharifov.
Yep.
And we will be presenting to you to get collectively together our week 4 presentation. First of all, to talk about the future of databases, we really need to understand the previous databases and how they came about a little bit, and then about database design. Database types, there are 2 of them that are out there today that are in standard mainstream. They're relational and non-relational. As far as database management systems, you have Microsoft Access, Microsoft SQL, Oracle, and then some non-SQL databases that are MongoDB, and there's a few others that we will go into in a little bit. And then we will finish up this discussion with about database design and the proper process for how database design occurs. First of all, relational databases. Relational databases, they are more of a rigid and tabular style like Excel. They can be clustered one-to-one and can really only be sized more vertically by adding more CPU, memory, disk space. They cannot go past a one-to-one relationship. Most databases that you find in big organizations, they run that way. They either have a single instance running to service that specific database need, or they are clustered across different locations for high availability, but they are limited in how big they can grow. Some of those examples that you've seen people use Microsoft Access. There's an older database called DB2, there's Oracle, there's Microsoft SQL, and then there's MaxDB. And we'll kind of go in a little bit about how database design works so you understand what that means by they are only vertically or horizontally capable. So being vertically, it means you have an active system or an active passive cluster or a single instance. So an active system is where you have 2 nodes that are capable of taking in reads and writes into that database. If one of the node fails, if say node 1, the active node fails, anybody who's processing transactions for that node gets moved over to the second node. They really don't notice a break in that activity, and everything keeps flowing, the system keeps processing. Good for large ERP systems, EMRs. Then you have what's called an active passive system, where you have one active node that's running everything. And if that active node were to go down, the passive node then gets moved over to being the active node. Now, when you have that scenario, there is a couple minute shift where it takes a minute or 2 for that system to shift over. Users do notice it, but then the system just self-heals on its own. This is good for other systems that can support that and having that active passive node, and it keeps an additional availability that if there is a failure, systems can restore on their own and keep on moving. The nice part is, while relational databases run in this model, you can have that hybrid where you have an active RDBMS, but then you can also have a non-SQL for your transaction logs, for your audit logs, for reporting and other things. And here's where a non-relational really comes into that benefit too, is that NoSQL databases are more non-tabular, and they are capable of horizontal and vertical scaling to maximize what the needs for work efforts. They can be put on smaller nodes, so that way you can get a lot of nodes running for faster capabilities and can run in a many-to-many environment. These work well for data warehouses. Again, they're good for like transaction logs, audit logs, and reporting needs. And the nice part is the database management, there's different vendors that are out there for that. MongoDB, CouchDB, DynamoDB is Amazon. There's a lot of different solutions that are coming to the market for those. And here's kind of how a NoSQL high availability is. You can have read writes being performed on multiple nodes in multiple countries. If one node were to ever fail, nobody even notices it. All the read writes just auto relevel through the routing source, and it will automatically move people around. People will not notice it. And as long as you have more than one read write environment, it keeps everything high availability. Nice part, this allows you to scale both vertically and horizontally. It increases read writes, throughputs for faster searching, faster writing, faster automation, and you can move your system along the globe of where you're actually performing your need for your work and what your organization is doing with the data. So here again, if your EU instance go down, everything is just being processed out of the United States. No one will ever notice where the failure occurs at. Now we're going to get into database design. I'm going to hand this over to Sherzod.
Yeah, and this database design, so data modeling is the process of creating data model for the data to be stored in the database. So the first is defining the requirements. So in this phase, we identified information, collected the requirement data, and when the next one, it passes to the conceptual phase. It's usually just includes the main concept requirements to store the information and the relationship that exists between the entities. And then it goes to the next, the logical phase. It's just probably the most used data model, and it goes beyond the conceptual model. And it includes entities, relationships, and different attributes, and unique ways to identify the entities like the primary keys and the foreign keys. And the next phase would be the physical. I believe this model is usually derived from the logical model, and then and it's stored to the relation database management system. One of the biggest difference between logical and physical data model is that we know where it needs to use the table and column names rather than the specifying entity and attribute names. And coming to the next slide, we can see the relationship between the employee, department, schedule, and the check history and rates. So this is the ER diagram, and then we can see the clear the data flow, which is like we can see the employee and the schedule as a relationship between the work hours, and we can see the department and employee has a relationship between the works for the department, the employee works for the department, and it goes so on. And also the rate, the schedule and rate, the relationship as a rate, how much is that? So this is the relationship between schedule and rate. So coming to the next slide, we can see the logical and the physical model, which is usually there is a relationship between the one-to-many, one-to-one, many-to-many, we can see, and logical and physical. This is the next stage after the one previous slide. I think that's it from my end. Do you have anything addition to this slide or questions?
No, and then just the future, as we talk about it together, I think me and Sherzod believe that we do like this approach, that, you know, there's, without spending that time and going back to identify how the workflow is required, identifying the right logical design of the database, and then getting into the right physical design so that, you know, the infrastructure side can support the growth, the scaling needed, the logical design supports the end user requirements, and that beginning supports how that database is created, instead of it being more of just, I need a bunch of data, really works. And it allows us to support it. And then it builds into how do you governance the data, how do you put sensitivity or labels around it, how do you protect that data, how do you secure it effectively. So these are good stages to have. It's good documentation that you can share over after your database is starting to get further along your implementation, to security teams, to other people in the organization, so they can easily use it too. Our questions that we have are, you know, one of mine is, considering the capstone project and the project you will be addressing, which type of database are you selecting? And are you planning on a cloud or an on-prem solution? And just why did you choose that one? Second one is, what database models will you be providing inside of your documentation? You know, and any tools, I think it'd be a good share that, so as other people are maybe struggling through this section, they could look at some of the tools that they've used. For our ULM, I was using Visio for a lot of those. So, and then during your master's degree journey, what was one of your issues that you ran into during your database design work? And what value did you find by creating a data dictionary or your physical or logical diagram? And Sherzod?
And my question would be that what are the three database design steps that you know. And the next one is, what are the two main types of database schemas that's used mostly? And that would be my question.
All right. Here's just a slide with some of our references for what we've used for some of this data. We also provide you some good reading material for reference data on this. We look forward to your questions this week, and thank you very much.
Thank you.